Hey guys, we wanted to create these videos just to give you maybe a little bit more of a review on naming, just to make sure you have all the resources you can get. So the first part of the video will just be looking at ionic naming and writing the formulas for ionic compounds. Just real briefly, we've studied two types of compounds so far in this chapter. The first type was an ionic compound, which is between two elements where the electrons are transferred. Typically these are metals and nonmetals, are cations and anions. Covalent bonds are when the electrons are shared equally between the two elements, and again this is typically between two nonmetals. And the electrons that we're referring to, the transfer and the share, are our valence electrons, which is why we can use the charges on the top of the periodic tables for the families. Okay, just looking at ionic compounds first, again, typically between a metal and a nonmetal are a cation and an anion. This is where electrons are transferred. Just to give you an example, NaCl would be a ionic compound because sodium is a metal, chlorine is a nonmetal. This right here, by the way, is a chemical formula. So if we ask you for a chemical formula, it's the symbol of the compound that we're looking for. So the way these are created, we've got to look at our charge. And with our charges of our elements, we're trying to make neutral compounds. The whole idea of neutral means that the charges add up to equal 0. So let's say we're putting sodium, which is Na+1, and oxygen, which is O minus 2. We're trying to get them together. Well, sodium plus 1 and oxygen minus 2 don't equal 0. Plus 1 minus 2 gives us a minus 1. So that's a problem. Well, what we can do is add another sodium. And what this now gives us is two positives, so right here, and one negative 2, which does add up to equal 0, which gives us a neutral compound. And the way we write that is two sodiums, Na2, remember this bottom subscript represents how many, and one oxygen, and we don't write the 1 typically. So that's kind of how we get that. Now an easier way that we talked about is called the cross and drop. Instead of trying to figure out how many sodiums it takes to cancel out how many oxygens, what we can do is bring down the charges, and it works itself out perfectly that way. So the 2 comes down to sodium, and the 1 comes down to oxygen. Now notice this is not a negative 2 like it is up here. That's because when it's on top, it's a charge, and when it's down at the bottom, it's a counting number. And remember, counting numbers are always positive. It's how many you have. So here, this tells us that we need 2 sodiums for every 1 oxygen. They're ratios, in other words. So 2 sodiums, 2 positive 1s, 1 oxygen, 1 negative 2, cancels out to equal 0. So just to look at another one, calcium and oxygen, Ca plus 2, oxygen negative 2, cross and drop our charges, we get Ca2O2. Remember that when these numbers, because they are ratios, can be simplified, we simplify them. So instead of Ca2O2, we just have CaO. Same goes if I have 2 and 4, 3 and 6, 6 and 4, etc. Anytime these numbers can be simplified, we do simplify them. So just keep that in mind as well. Writing the name for ionic compounds. We're first just going to look at simple binary. Binary basically means that it doesn't have a polyatomic ion in it. Then we'll look at polyatomic ions towards the end of this. What we do is exactly what we've been doing in class. We name the metal first, exactly like it is off the periodic table. We do not change the name. We do not add anything to it. It's just the metal's name. Now the non-metal, on the other hand, is exactly what we've also been doing in class. We take the non-metal's name, off the periodic table, and change the ending to IDE. So let's look at that. Okay, Na2O. Na is sodium, so I'm simply just going to name sodium directly as it is off the periodic table. O is oxygen, so I'm going to change the ending of oxygen to IDE and name it oxide. So Na2O is sodium oxide. Notice I'm not saying anything about the 2 in my compound. That's because I don't have to. Sodium is always Na+1. Oxygen is always O negative 2, which means when I cross and drop these charges, I'm always going to get Na2O when sodium and oxygen combine. So sodium oxide is always Na2O. I don't ever have to worry about the numbers there because they're kind of assumed or understood by the name of the compound. If we know the name of the compound, we know the element's charges, we can come up with a compound. Okay, looking at another one, CaCl2, Ca, calcium, just going to name it Cl, chlorine, change the ending to IDE. And again, not saying anything about the 2 because it's understood. Calcium's a +2, chlorine's a -1. Cross and swap, CaCl2. Okay, and working the name to the compound, let's work it that way. Let's say I've got strontium oxide. What I'm going to do, I'm going to look at the elements off the periodic table with their charges. So strontium oxide. Strontium is Sr with a +2 charge. Oxygen is O -2. I'm going to cross and drop my 2's, and I get Sr2, O2, and again, of course, we simplify because the 2's can't be simplified. Another couple examples. Let's just go through these kind of quickly. We've got sodium, which is Na+, nitride, which is N -3. Cross and drop our charges. We get Na3N. Calcium chloride, Ca +2, chloride Cl -1, and remember these charges are coming off the top of your periodic table where you should have the charges written, but they're also the charges of the families. Cross and drop, CaCl2. Aluminum is Al +3, sulfide is sulfur, -2 charge, cross and swap, Al2S3. Barium fluoride, Ba +2, fluoride is F-1, cross and drop, and we get BaF2. Let's try naming them. Li2O. Li is lithium, so I'm just going to name my metal lithium. O is oxygen, so I change the ending to oxide. GaP. Ga is gallium, so I'm just going to name gallium. P is phosphorus, so I'm going to change my ending to phosphide. Magnesium and iodine make, oops, sorry, let me try that again. There we go, magnesium iodide, and Ca3N2 is calcium nitride. Okay, so pretty simple for the most part. Now, let's add a little bit of a wrench into this and look at transition metals. Remember, transition metals are given their name because they have multiple oxidation states or charges. So, for example, iron can be Fe2 or Fe3. Give you some more examples just so you can see how many different charges some can have. Chromium has a bunch, molybdenum has a bunch, ruthenium has a bunch, nickel only really has one, silver only has one, zinc has one, so we kind of have all these different charges, which makes it problematic with naming. How do we know if we're dealing with iron +2 or iron +3? That's when we have to use the Roman numerals. So let's say this is our compound right here. We are looking at FeCl3. Well, I know based off of what I just learned, Fe is iron, so I just name iron. Chlorine is chlorine, so we name it, or Cl is chlorine, so we name it chloride. Okay, but what iron is this? We use Roman numerals to identify what his charge is, and the way we do that is by uncrossing and unswapping. Okay, we bring up our numeric values, and we'll look at that on the next slide. Okay, so we bring up the 3, we bring up the 1. Iron is a +3 charge, chlorine is a -1 charge. Always double check because you need to make sure that's still true. Chlorine is supposed to be a -1, so iron must be a +3. So now we name this iron 3, and I put them in parentheses. You don't have to. I know Mr. Akins doesn't typically use the parentheses when he's writing these, so I do. It doesn't really matter. Neither way is right or wrong. It just depends on how you learn it. So iron 3 represents iron +3, and chlorine is still chloride. Okay, so looking at another example, bring up the 1s, because remember, if we don't show anything down here, they're automatically 1s. Iron is a +1, oxygen's a -1. Okay, but this is why we double check. Oxygen's not a -1. It's supposed to be a -2. Well, where'd the 2 go in the compound? It must have simplified. So if oxygen is a -2, or supposed to be a -2, okay, that means iron must be a +2. That's the only way they simplify to both being 1s. So now that we know iron's a +2 and oxygen's a -2, we now name this iron 2 oxide. Okay? So, when we're naming this, sorry, that looks like a repeat slide. Let's keep going. Let's practice some of these. NnO2, we bring up our charges, so we get Nn plus 1, O minus 1. Of course, again, oxygen's not supposed to be a minus 1, it's supposed to be a minus 2. So if it's a minus 2, manganese must be a plus 2. They have to be the same charge if they're both canceling out to equal 1. So now we name this manganese 2 oxide. Okay, cobalt with fluorine, bring up the 2, bring up the 1, we get CO plus 2, F minus 1. Fluorine is supposed to be a minus 1, cobalt is supposed to be a plus 2 then, so we name it cobalt 2 fluoride. Okay, basically the reason we double check, because if our anion is the correct charge, which we know from the periodic table, then our cation also must be the correct charge. So like up here, oxygen's not a negative 1, which means manganese is not a positive 1. Oxygen's a negative 2, which means manganese must be a plus 2 for them to cancel out and give us 1s. So same thing down here, bring up the 2, bring up the 1, we get palladium plus 1, and we get sulfur negative 2. Again, sulfur is supposed to be a negative 2 based off our periodic table, which means palladium must be a positive 1. Okay, so palladium, 1, and then sulfur becomes sulfide. And we do always show the 1 in our Roman numerals. I know we don't show the 1s in the compounds because it's understood, but it's not understood in the name. If you don't have a Roman numeral, we don't know if you meant to put 1 or if you just forgot to get a Roman numeral because you don't know to give a Roman numeral. So you do always have to show the 1 in the Roman numeral. Okay, next one, bring up the 2, bring up the 3, we get Fe plus 2, and N minus 3. Okay, so once we have that information, we name it, and it's going to be named iron 2 nitride. Okay, silver is one of the fun ones. Silver is always a plus 1, so Mr. Akins and I do not need you to give his Roman numeral, so this would just be simply silver chloride. And then we could do the same thing with the chromium, as we've been doing with the other ones. We get chromium plus 1, oxygen minus 2, so we name it chromium 1 oxide. Okay, so not too bad, just requires a little bit of extra work. And then of course working them backwards are writing out the numbers. Remember, this is the charge for the transition metal, so we write out our ion with that charge, write out the anion with that charge, and just cross and swap. So let's just practice some of those real quick. Iron 3 oxide is Fe plus 3, oxygen minus 2, cross and swap, Fe2, O3. Molybdenum 2 phosphide is Mo plus 2, phosphide is P negative 3, cross and swap, MO3, P2. Vanadium 1 sulfide, V plus 1, S minus 2, cross and swap, V2S. And last one, chromium 4 chloride is Cr plus 4, Cl minus 1, cross and swap, Cr, Cl4. And you could also have one with chromium. Let's do that one real quick. Chromium 4, let's say oxide. Okay, well chromium 4 would be Cr plus 4, just like it was above in the next one, or above this one. Oxygen's negative 2. Well, in this case, when we cross and swap, we get Cr2O4, which simplifies into CrO2. So don't forget with these that you're still simplifying. Okay, so that's it for this video. I will make another video for ionic compound naming, including the polyatomic ions, because we're obviously not done with ionic naming yet. And then at the end of that video, I'll do some review with a bunch of different ionic compounds where we can just go through and practice how we would name them and how we would write their compounds. So thanks for watching.